Hello everyone, this is Professor Yalo. I am your instructor for this course, Flutter and Dart programming, which is a new type of programming. This is a summary of our syllabus. You can see my email here. If you have any question, you can email me, or you can use the CTL system. For the time being, we don't have any teaching assistant, and in our course we'll have midterm, final exam, projects, and when you are in class, there will be some class participation and attendance required also. These are some policies for classroom, so it's not important. If you want to talk to me, you can visit my office on Tuesday from 1600 to 800, and we do not use any specific textbook for this course. Rather, we just provide some instruction or some slides by me and by whom will be my TA. So without further ado, let's start our class. These are the contents of this chapter, or the first chapter. My plan was to give you an overview of what we are going to do, and then set up some compiling and running or programming development tools. But the problem is we cannot do that now, as this is a video instruction, so we'll skip that part for the video instruction, and as soon as we start class, we'll start from there. So the first thing we'll have to talk about is the generic computer diagram. So this is what a general computer looks like. So it has some storage where you store your computer programs and softwares and data, and you have other peripherals such as printers, speakers, and some touchpads and joysticks. And you have the central processing unit. This is like the brain of the computer. It is the part of the computer or component of the computer that understands what a human being or the user wants, and gives orders or instructions to the other peripherals. And the main memory is kind of a space where currently running softwares are stored in. For instance, in your computer you may have Excel, Microsoft Word, or Google Chrome browser, and maybe other movie players. So there are multiple softwares that are used in your computers, but you do not use all of those softwares at all time. So what you do is you store all of those softwares in your storage, and whenever you want to use one software, that software will be loaded into the main memory or the main storage, and then the CPU can read instructions from this main memory to give instructions or to give orders to the other peripherals. We'll see why we have to use two types of storage in the coming slides. And when you are thinking, because these days most of the students are interacting with mobile devices and tablets, you can think of, for instance, keyboards and mouses as touch screens and stylus pens, and to store your data, instead of hard disk or secondary storage, you use SSD, and instead of the internet cable, you use Wi-Fi and LTE. So basically they have similar components in mobile devices as well. So why do we need to understand this computer diagram or the hardware components of a computer? Because we are going to learn a program, we are going to learn programming, and programming is all about interacting with these components of a computer. So understanding the building blocks of a computer helps you to understand why you are programming and how you can efficiently use your components or the hardware components. So basically, the computer components can be categorized into three categories. The first is CPU, or the central processing unit, which is made of some chips and transistors. And the second category is storage, which has primary storage, secondary storage, and removable storage. However, removable storage are actually part of our classes of secondary storage. And we have some peripherals. The peripherals are such as mouse and keyboards and printers and the speakers. They are general purpose devices. Why we call them general purpose devices is because they are only responsible for doing a simple task. So for instance, your computer can play, or your CPU can play media, or it can allow you to browse on the internet, or it can allow you to write your essay on Microsoft Word. However, your speaker only give an output sound, or it allows a sound to come out of your computer. So it doesn't do multiple tasks. And the keyboard is only for typing and entering some data. It does not do multiple tasks. So these are peripherals. This is why we call peripherals. They are general purpose devices, and they execute very simple instructions, and they execute instructions very, very rapidly and very, very fast. And your task is to be able to write a program to interact with these peripherals and to give instructions. So we say that, okay, we have a hardware of a computer, and the hardware of the computer should be programmed. So computers then become machines that perform certain tasks. So we have cars, for instance, right? Cars are also machines, but cars can only do one task. For instance, cars can only be driven, right? But computers are machines that can be programmed to perform multiple tasks. That means you can be able to browse on the internet, you can be able to store your data or your phone number on the internet, you can be able to see a movie on the computer. So there are multiple tasks, and multiple tasks or different tasks equals different programs. For each task we need different programs handling that task. And a program is basically what allows a task to be performed. So what a program is, it is a set of instructions that can be executed sequentially. Actually, a program is a set of instructions that can be programmed sequentially in order to perform certain tasks. That means when you write a program, you write certain lines of instructions. And these instructions are read line by line so that the task you want to perform is completed. Sometimes, actually most of the time, when you want to write a very complex and complicated program, you need a very large set of highly skilled programmers and other professionals. Because other professionals should tell you how they want to use the computer or how the computer will be used. So it's not only programmers that are required to develop a program or to develop a software in this case. And finally, then we can answer the question, what is a programming? Or what is programming? Programming is the process of writing a program using certain language. So, for instance, for writing Korean, we use Korean letters. For writing English, we use English letters. So for writing a program, we also use different languages. We can use probably, I assume, if you are taking this course, you already have an experience with C++, Python, or Java. So we can use either of those programming language to write a program. And the programming is the process of writing this program so that the computer performs certain task. And in that case, what a programmer will become is a person who writes instructions, basically, or a person who writes programs to make a computer perform a task. So without a computer, without a programmer, there is no program. Without a program, there is nothing a computer can do. And why do we need programs? Because they allow us to simplify our life. And they allow us to do certain things such as search for information, know our locations, maybe store the phone numbers of our friends. So they allow us to remember and to know things. So they simplify our daily life. They also help us measure some scientific measurements which advance human civilizations. So once a program is written or once a software is developed, where is it stored? So you write your program and this program performs certain tasks. You all know that thing. So this program is actually stored in a secondary storage, or what we call ROM, or read-only memory. And once it's stored in the ROM, it is actually loaded into the primary storage for execution or usage. So if you're not going to use, when you are not going to use this program, it is stored in the ROM, and then when you start using this program, it will be loaded to the main memory. Think of this as learning all the vocabulary, the grammar, and the punctuations of English language. And then when you want to make a sentence, you just use a specific word or a specific set of words and some grammar rules such as past tense and present tense and future tense to make a simple sentence. So whenever you don't use that grammar and syntax, it's just stored in your brain. And why can't we store? So your question would be that, oh, if both of these are storage, why can't we store all of the program in our RAM or random access memory or primary storage? Because primary storage it has very limited resource. So we cannot store everything in our primary storage. We'll see why we cannot do that in the next slide. So when you are writing a program, one of the tasks is to actually write a program that improves the usage of RAM, or that improves RAM efficiency. Here is why we cannot use main memory for storing all of our data. So as you can see from this, first from this figure, let's say you store all of the programs in the secondary storage and you want to fetch data from the CPU, because the CPU is the component that executes the instructions written by the programmer. So if you want to fetch and execute the instruction from the secondary storage, then this is very, very slow. So it will take too long to process one program or to execute one instruction. Therefore, it's better if we load just a program to be executed into the main memory, and then we fetch instruction to the CPU. Then that is a little bit faster. But the best part is actually fetching an instruction of a program to cache and then execute it in the CPU. So imagine you have 5 programs. You have Microsoft Word, you have Google Chrome, you have KakaoTalk, you have Internet Browser, and one other program. So when you use KakaoTalk, then KakaoTalk is loaded into the main memory, and then each instruction from KakaoTalk is loaded into the cache and then executed by the CPU. Why can't we put all instructions of KakaoTalk into the cache? Into the cache or the main memory, because these are limited resources, and if you want to put all of this the program in this storage, it will be too expensive, which is shown in this diagram. So the auxiliary memory or the secondary storage memory has a large space. It gives us large space, but it is very, very slow. However, how about the cache? The cache has a smaller size, but it provides us speed. Okay, if it can provide us with a faster speed, why can't we use it? Because the cost of actually manufacturing cache type memories is very, very high. So if you want to build a computer which has cache as a storage, then it will be too expensive. It will cost probably thousands of dollars, $5 or $10,000, which is pretty expensive, and it is not suitable to bring a computer to every user. So what we do is, when we have 100 programs, we store 100 programs here, and we only load maybe 1 or 2 programs into the main memory, which makes it faster for us to process. So the reason why we do not have the reason why we do not store all the programs in the main memory is shown in this program. So every time you program, you also have to think about how to efficiently use your main memory. How does the main memory actually store your program? The main memory actually stores both program instructions and data. What does it mean? For instance, if you want to add 2 plus 3, then the instruction is addition and the data is 2 and 3. So the memory stores the data 2 and 3 and the instruction addition. And the CPU understands this instruction. Oh, okay, now the computer or this program wants to add these two data and maybe display it on the monitor. So it will fetch this instruction from the memory, adds 2 plus 2 and 3, and then display 5. But when we store data in the computer, we do not actually store the characters that you see or the numbers that you see in the computer. So these letters are actually not stored in the computer. They have to be changed into binary system, because then binary system can be represented by the presence and absence of electromagnetic energy. So here you can see that, for instance, one character is represented by 8 bits, and these 8 bits can be, for instance, this can be negative, positive, positive, then negative, negative, then positive, positive, positive. So because that's the way the computer understands only electromagnetic signals. And the system or the number system that is close to electromagnetic signal is binary system. And whenever we have a character or a symbol, that symbol is first changed into a hexadecimal, then the hexadecimal is changed into a binary system, and the binary system is understood by the computer. Because as you can see here, that these bits have the value of 0, off, that means the absence of electrons or electricity, and this is, the absence of signal, and this is the presence of signal, which is on. And when you have 8 bits together, you call them bytes. And 4 consecutive bytes are actually called words. So whenever you write an instruction for a computer, that instruction is organized into words, and the CPU reads one word. So for us, a word is just, for instance, this is a word, right? Or thank you. No, thanks is a word. But for a computer, it is just 4 consecutive bytes. That means 4 bytes, that means just 32 bits is a word. So it reads that and executes the instruction. So the reason why you have to understand this is because when you write a program, you have to understand how the main memory stores your program. And when you write a bulky and large program, it is actually inefficient, which would lead to resource wastage. So this is how the computer stores your program. And then let's see what is the role of the CPU. The role of the CPU, before we talk about the role of the CPU, actually, the CPU itself is divided into 2, which is the control unit and the arithmetic logic unit. So the role of the CPU is to fetch input and then decode the input and execute, and then finally give the result of the execution as an output. So when you have 2 plus 3 in the memory, the role of the CPU is get 2, then get 3, and then add them, and then return 5, or give you display 5 in the monitor. Now you understand how the main memory stores the data and how the CPU interacts with the main memory in order to fetch, decode, and execute instruction. Let's see how you can be able to write a program, or to understand writing a program in the layman term. So writing a program is actually like writing a book. Think of a person who was born, went to a prison, and then get a freedom. So this person can divide his book into 3 parts. Part 1 is maybe talking about his childhood. Part 2 is talking about the time he had spent in the prison, and part 3 is talking about his freedom. So when you write a program, you can think of, first you have to divide the program into multiple compartments. So the same thing. Part 1 is probably talking about the user interface. Part 2 is talking about the logic, and part 3 is about storing that the data that interacts with the program. So you can think of, every time you write a program, oh, okay, I'm writing a book, and what parts does this program have, and how can I divide these parts into sections? So there are 3 steps for writing a typical program. You have to think all the time. The 3 steps of writing a program is gathering an input or data, as I have already shown or explained in the addition example. We gather data from the keyboard or from files on the disk or from the database, and we process that data, and then we display the result as an output. Either we display it on the screen, or we write it, or we save it into a file. So what type of programs do you use in your daily life that does all these 3 steps? You have 2 types of programs. There are operating systems and there are application softwares, which we mainly focus on in this class. Operating systems are programs that manage actually the hardware or part of the computer. And there are multiple ways of classifying operating systems. For instance, we can classify them based on how many programs they run at one time. There are programs that run just one program at one time, which are called single tasking, and there are programs that run multiple programs at one time, which are called multitasking. And we can also classify programs based on how many people can use the computer at the same time. And in this case, we have single user and multi-user. And the task of this operating system, as I've already said, is just to see or to manage how the hardware operates. But we have application softwares, and the application software provides service to the user. Application softwares can be word processing, games, programs to solve specific problems such as calculators and other things. Application softwares these days are actually called mobile and web apps. So apps is a shorthand for apps. Apps is a shorthand for applications. So what is application software? Application software is just actually a software that run on mobile devices and web browsers. And our goal or our dream is to build applications that run on multiple platforms. To write an application program for each device or each mobile system, such as Windows, Android, and iOS, in the previous cases, we used just different programming language. For instance, for Windows Phone, we use C#. For Android device, we use Java. For iOS, we use Swift or Objective-C. That means a company such as KakaoTalk, when they develop application for Windows or for iOS or for Android, they have to have different type of developers, and they have to write different type of code for each device. That means you either need developers with multiple skill sets, or you want multiple developers with a single skill set, which is very expensive. And most of the time, the apps that you develop look different on each platform. So this is the problem that we have on current softwares and current programs. So when we develop a program, we have to take a look at all these sorts of problems. What are the problems of the program, developing a program? We have to take a look at all these things. So there is a process actually in developing a program. We just don't wake up and write a program. First, we have to understand the problem. Oh, okay, this is a problem for Android. This is a problem for iOS. Or this is a problem for video playing. This is a problem for calculation or developing calculator and other softwares or other apps. Once we understand the problem, we have to develop an algorithm. What is an algorithm? I'll describe on the next slide. And then we test the algorithm with different inputs and then translate the algorithm into kind of a pseudocode. Then we translate it into a real code or a real program, which can be read and understood by the CPU. Then we compile that program and see if there is an error. And if there is an error, we debug that program and then we continue to develop the program until the program becomes error-free, and that program or that software or that application will be used by humans. So you can see that once we understood the problem, we have to actually write an algorithm. So what is an algorithm? An algorithm is a sequence of steps that is unambiguous, executable, and terminating. For instance, when you wake up in the morning, you wake up, you wash your face, you go to the kitchen, you bring a bowl and a cereal and a milk, you put the cereal, then the milk, and then you start eating your breakfast. So these are the sequence of steps that you take after you wake up from your sleep. The same thing when you try to develop a program, you have to first understand the problem and write a sequence of steps. So for instance, take a look at this example. For a person who wants to buy a car, what we do is first we compute the total cost of each car. Let's say I choose 10 cars and then I have to decide which car is the best car and which car is the most efficient car, right? So first I calculate the annual fuel consumed and I calculate the annual fuel cost. Then I will calculate the operating cost. The operating cost is the cost that you spend for service, car wash, and other things. And then finally, the total cost is the purchase cost plus the operating cost. So the annual fuel consumed is the annual miles driven per fuel efficiency. The annual fuel cost is price per gallon times annual fuel consumed, how much you will consume. And then once you calculate the total cost of each car, then you can compare whether the total cost of car 1 is less than the total cost of car 2. If it is, then you choose car 2. If it is not, or otherwise, you'll choose car number 2. If the total cost of car 1 is less than total cost of car 2, you choose car 1, otherwise you choose car 2. So by doing these steps, it's easy for you now to understand which car to buy or to decide which car to buy. So when you write a program, the same thing. First, take input from the keyboard and then add the two numbers and then display the result on the keyboard. You have to write sequence of steps. And after you write the algorithm, actually you have to translate it into a pseudocode. A pseudocode is a middle, how to say, a middle level before you jump in and write a program into a computer which can be understood by the CPU or which can be translated by the CPU. So this will help you understand what you are going to write in the computer. So it's an informal description of the algorithm. So you can see that this is the pseudocode of our first algorithm. We describe how the value is set or changed, and we describe the decision and the repetition, and then we indicate the result. So this is kind of the description of our previous algorithm. And once you write the algorithm, now you understand, oh, okay, this is what I have to do. So you can go on and write your program on your editor. But when you write a program, you might encounter errors. What is an error? An error is actually kind of a condition that prevents your program from running, or that prevents your program from being executed by the CPU. An error can be violating a programming language rule. So we say that when you write a program, you use a programming language. And each language actually have its own rule. And if you violate that rule, it is called a compile time error or a syntax error. For instance, in our Dart programming and Dart and Flutter programming, after you write one statement, you have to have a semicolon at the end. If you don't have that semicolon, then the compiler will say some error or display some error. However, all errors are not violation of programming rule. Sometimes you violate logic. For instance, dividing numbers by 0. It is not mathematically logical to divide any number by 0, right? The computer cannot see this error actually. When you write it, it will not recognize it as a language violation, because here you are not violating the language. Rather, you are violating a logic. In this case, we call it a runtime error, or also it is known as a logic error. And you will know this, or you will know you made a mistake once you run the program or after you run the program. So how do you avoid these errors, right? So if an error prevents your program from running, how do you avoid this error? The best way is actually to learn about errors and to become an expert in coding. So the more you work, the more you understand what causes error and what the error message will say, and then you'll be able to fix it. So only experience can help you avoid errors. Now you know about what is programming and how to program, and how to develop your program. We'll see, or we'll talk about some of the or one of the programming language that we'll use. So among the programming language, as I have discussed earlier, Kotlin, Swift, or Python, or Dart, Python, or Java. For this class, we chose Dart. Why do we choose Dart? Because Dart is actually a general purpose programming language. That means, unlike Java, unlike C#, if you run or if you write a Dart code once, you can run it everywhere. That means you don't have to develop a program for each device or for each mobile devices. What are the benefits of Dart? Dart is an open source which can be transcompiled into JavaScript. That means it can be changed into JavaScript. It is very cheap, and unlike other language or unlike other programming language, it looks the same on different platforms, and it is easy for developers with object-oriented programming coding experience. And the reason why we are learning Dart is because Flutter, which is a framework, uses Dart. That is the main reason why we study Dart, is because we want to work with Flutter. And what is Flutter? Flutter is actually a user interface framework to create a native mobile application that we can use in our mobile. And this framework has two parts. First, it has SDK, or software development kit, that help us write, compile, and debug. Debug means find the error in your Dart code. And it also have a framework which gives us a reusable user interface elements. What are user interface elements? User interface elements are just buttons, text inputs, and scrolls. Without SDK, actually, you have to write your code in text editors, such as Notepad, and then compile and run your program from terminals, such as CMD. And there is no autocomplete. That means you have to write each word, which is very, and without a framework, actually, you have to create each user interface component. That means you have to create a button or a slider or a text box, which is very complicated. So we have Flutter, which will help us or solve these problems. So it will help us write native mobile applications by solving these issues. What other frameworks are available to write a cross-platform program? We have React Native, which is by Facebook and uses JavaScript. And the good thing about this React Native is there are already trained JavaScript developers, and it has been here since 2015. And the other one is Xamarin. Xamarin is by Microsoft, which uses C#. And the good thing also about this is there are already trained developers, and it has been here since 2011. There are also other frameworks such as PhoneGap, Cordova, and Iconic. And this is a survey from Stack Overflow, why we actually use Flutter instead of the other programs. So if you can see this, the most loved and dreaded and wanted frameworks, libraries, and tools. You can see that compared to React Native, Xamarin, and Cordova, Flutter is loved by many, or it is said to become one of the top mobile development frameworks. And as you can see that from Google Trends, we can see the search trends, and you can see that at this point in time, Flutter becomes the most searched framework in Google. So since it is the future of mobile application development, we'll study this program. So what are other comparisons between Flutter and other platforms? So here you can see that there is a comparison for vector graphics, and Flutter supports vector graphics, not supportable, and not supportable by Xamarin 2. That means if it is not supporting vector graphics, then the graphics will look a little bit squishy in multiple platforms. So the best part about Flutter is supporting vector platform. That means it looks native on different mobile devices, whether it is Android or iOS or Windows. And it has widget, it has native functionality, and you can see Flutter provides all the native functionalities of the underlying operating system, whereas the others does not support. And there is actually, the problem is there is less code reusability. With React Native, there is 90% code reusability, and with Xamarin, up to 95% code reusability. And you can see which popular apps use different systems. and you can see that there are more apps developed by Flutter instead of the others, and you can see that they have the React Native has lots of bugs, and Xamarin also have lots of bugs. Having said this, our goal, if this was in class, was to set up an IDE and framework for Flutter, but we are not going to be able to do that. So later, when we come back to class, I'll show you how to do this. But for the time being, we'll end our class here.